Hi. Um, Today's question related to hypothesis. Actually, this is all about hypothesis. Okay, let's start the question. The question is to compare the average income of two cities. Researchers take a sample of 100 households from each city and found that the sample means were 30,000 and 32,000 Canadian dollars. Let's take some draft. Two cities, let's say that city A and city B, and a sample mean 100 and sample of city B and B equal 100, and sample means mu A equal 30,000 and mu B equal 32,000. What else? With standard deviation of 1000 and 9000, means that SA equal 1000, SB equal 9000. Standard deviation respectively with the standard deviation, it means that the sample of these household. So that's why I use big S instead of sigma. Using a significance level of 0.1, it means that they are given alpha equal 0.1. Test the hypothesis that there is no difference. So this is the most important trick. There is no difference in average income between the cities, between city A and city B. Okay, let's see the question number A. Write down the null and alternative hypothesis. So null and alternative H1 or HA, it could be H1 or HA, right? We see there is no significant difference. It means that mu A minus mu B 0, no difference. So the question is all about alternative hypothesis. So easily we can write null hypothesis. It means that mu A minus mu B equals 0. So it is a small trick for this kind of hypothesis problem. And before that you have to write mu A, you have to define mu A and mu B, right? And part B, this is part A, this is part B. It asks compute an appropriate test statistic. How we identify the test statistic? See, this question has large sample. What? Large samples. And do you know the population variance? No. They weren't gave the population variance. So it is unknown variance. So now you know the two points. This has large samples and unknown variance. So definitely you have to go for a Z test. X A bar minus X B bar divided by S A squared N A plus S B squared N B all square root. So I made a mistake here. This should be XA, right? Not mu A. Because this is all about samples. XA bar and XB bar, right? So you know the values for XA bar, XB bar, and SA and SB and NA and NB. So I got the solution minus 2.2086. Part C, write down an appropriate rejection region. Let's change the color. Rejection region. So they gave us the alpha level Z alpha over 2 equal Z 0.1 divided by 2 equal Z 0.05 equal 1.645. You can find this value using your table. Okay. Why we get alpha divided by 2 instead of alpha? Because this is a two-tail test. See, equal and not equal. It means that it is a two-tail test. So this curve has two tails. I'll show you. See, two-tail test. So that's why we divided alpha by 2. So what is our value? 1.6645, right? This is our rejection region. Sorry. Rejection region. And here also we have rejection region. Minus 1.645. So this is alpha over 2 and this is alpha over 2. In here 1 minus alpha. And the last question is make a conclusion. So you know the test statistic value that we calculated using this equation, and you know the table value, right? So test statistic value 2.2086 greater than our table value 645. It means that this value is in the rejection region 2.2086 in the rejection region, like kind of here. So it means that we have to reject the null hypothesis. Reject the null. Again, we can conclude that there is a significant difference. We reject this. It means that there is a significant difference in average income between city A and city B. So there is another thing I want you to say. In here we use only the value, numbers, not the sign. Here we got the minus 2.2086, but we compare only 2.2086. We don't care about the sign when we are going to conclude the conclude the final answer. We don't care about the sign, we care about only the value.